Welcome. In this lesson, hopefully this will be a review from last year when we introduced the sine, cosine, and tangent functions. These are trigonometric functions. The important thing is being able to realize that they're ratios of sides of right triangles. So over here I've written down that the sine of an angle is the opposite side over the hypotenuse, the cosine of an angle is the adjacent side over the hypotenuse, and the tangent of an angle is the opposite over the adjacent. Now let me explain to you what opposite, adjacent, hypotenuse means. When we look at a triangle, one of the sides will always be the hypotenuse, the longest side, the side that's across from the right angle. So it's neither of the sides that form the right angle, it's the side that does not. So I would label this as the hypotenuse right off the bat. Now, the opposite and the adjacent two sides, opposite and adjacent, depends on which angle we're referring to. So I did sine of A over here, but in the problem, it asked for the sine of F. F is this angle, so we're referring to this angle. If this is the angle we're looking at, then the side that makes angle F with the hypotenuse is the adjacent side, and the side that's across from the angle, that the side that does not form the angle F with the hypotenuse, is the opposite. Now we can easily find this ratio, because again, the sine function is a ratio of the opposite side's length, which is 56, over the hypotenuse's length, which is 65. And then always try to reduce if possible. I don't believe 65 and 56 have anything in common, so you would actually just type in that exact fraction, and it gives you that possibility, 56 over 65. And that's how we do this. So again, I'm going to leave these ratios right here, and we're going to do a couple more. Now, I'm going to jump ahead because I want to make sure I do some that will give us this ability, because we might have to use Pythagorean's theorem in order to do it. As we get up higher, so far, they've all been easy. Like for this one here, we don't know the hypotenuse, so we do Pythagorean's theorem. Hopefully you all remember Pythagorean's theorem. A squared plus b squared equals c squared, and we've had that lesson recently, so I'm going to do 70 squared plus 24 squared equals the hypotenuse squared. I'm going to now grab my calculator and do that. Now I just quickly did that, found out that the hypotenuse's length is 74, and now I'm going to find the sine of E. E is this angle. Sine is opposite, which will be this side here, over the hypotenuse. That's why I had to do Pythagorean's theorem. So it's 70 over 74, and I reduce that to, it looks like it would be 35 over 37, which that does not reduce. So that's what I type in. 35 over 37. I believe I can even do it that way. I think it accepts that. Yep, exactly. Again, jumping forward. So far, we've only done sine, so make sure you think about cosine and tangent. Like, for instance, this one's the tangent, which the tangent of u is right here. So tangent will be opposite, which is 12, over the adjacent, which is this side here, because this is the hypotenuse. And so I need to use Pythagorean's theorem, which 13 squared minus 12 squared, because I have the hypotenuse, is 25. Square root of 25 is 5. Now I know my fraction is opposite over adjacent, 5/12. Ooh, I almost did that backwards. Opposite of u is 12. It's 12/5. So be careful. 12 over 5. I almost did that backwards. Again, I'm hoping this lesson will be fairly simple for you. They'll throw in some square roots. Make sure you understand how to reduce your square roots, rationalize the denominator. If you have questions on how to do that, please let me know and I will help you.